this is the example professor raised in during the class, um, and the problem is to calculate the optimal alignment between two sequences, and we just recap about the what is the alignment between two sequences. Basically, an alignment is to introduce the so-called gap symbol and to make the two sequences equal length. And uh, under each alignment, we will define an a scoring scheme. So under this scoring scheme, we can calculate the optimum score under the scoring scheme to get the optimal alignment. Okay, so the problem a professor raised in class was to compare two sequences. The first one as AA, the second one as ACCA. And the scoring scheme is that if two characters in the same position is the same, then it's called a match. The score is +8. If the two characters are not not the same, then it's called a mismatch, and the score is -5. And if any of the sequence introduced, if in a position one of the sequence is an gap symbol, then the score is -3. And for any gap, there will be an additional uh, so-called gap open penalty for each gap. So for any gap of length k, it will be penalized with the penalty of x plus k times y. Okay, x is for every gap, and since your length is k, for each character you will be penalized with y. So the total penalty is x plus k times y. Okay, for example, for this two sequence, we introduce the gap symbol to make the two sequences equal length. Okay, so given the above alignment for the two sequences, so what is the alignment score for this alignment under the affine-gap-penalty scoring scheme we just introduced here? So let's see. So C, the first character is C for sequence 1, and the second character is also C, so it's a match. So the score will be +8. The second character for the sequence 1 is a gap symbol, and the second character for the second sequence is G. So it is a gap. Okay, so it is penalty will be 3, so it's -3. Similarly, for position 3 and position 4, they will also both of them will get penalized by -3. And don't forget that for each gap we will have an extra gap open penalty, so the total will be -4 plus k is equal to 3 times 4. Okay, and for each position we will calculate this kind of the score character by character and sum them up. So finally you can see the formula here. It's the first character, second one, second to the fourth one, and until to the end. So we sum them up, they will be 4. So you can just scrutinize over the detail. Well, I will not go over this in this video. Okay, so for each alignment, there will be 3 cases for its ending. The first scenario is that both sequence 1 and sequence 2 are an aligned pair. That is, AI equals BJ. The second case is that it's a deletion, meaning that sequence 2 will have a gap symbol here. The third scenario will be an insertion scenario. In this case, it is sequence 1 which has the gap symbol here. Okay, so this is the only three scenarios we will have. You may ask whether we'll have gap symbols at both sequence 1 and sequence 2, but it is not allowed by definition, so there will only be three scenarios. Okay, so let's define the notation. Let's call Dij as the maximum score of any alignment between A1 to AI and B1 to BJ, ending with a deletion. Don't forget a deletion, it meaning insinuates that the second sequence will end with a gap symbol. And we denote Ij as the maximum score of any alignment between A1 to AI and B1 to BJ, ending with an insertion. An insertion is a case when the gap symbol appears at the end of sequence 1. And finally, Sij means the maximum score of any alignment between A1 to AI and B1 to BJ. Okay. Okay. So let's look deeper or elaborate over what's Dij. The definition we reiterate it again, or reiterate the definition here, is the maximum score of any alignment between A1 to AI and B1 to BJ, ending with a deletion. And a deletion means the gap symbol will appear at the end of sequence at the second sequence. For this example, we have a sequence 1 from the first position A1 to the final position AI, and the second sequence starting from the character B1 to the final character BJ. And if we have a deletion alignment with and deletion ending, it means that the end will be a gap symbol as sequence B. Sorry, the annotation doesn't align with each other. So the second sequence, okay. So it's a gap here, which is a deletion case because the gap symbol appears at the end of sequence B. Okay, so what's the scenario for all the possible alignment ending with a deletion? Okay, so you have A1 to AI. AI must match with a gap symbol since it is a deletion, meaning that the final character must be a gap symbol. Okay, but there are a lot of cases where AI can match with a gap symbol here. It can be that AI and BJ let's say, let me think, sorry. Since AI cannot match with BJ because it has to match with a gap symbol, but you can, as you will, decide how many more characters you want to insert in between I and J. Okay, so all of this alignment, okay, all of this alignment will satisfy the condition for a deletion, because the deletion for a the definition for the deletion scenario only requires you to have a gap symbol for sequence B at the end. Okay, so we can calculate the scoring for each alignment. For this one, the scoring scheme will be Si minus 1 dot j, meaning that, don't forget the definition, Sij means the maximum score of any alignment between A1 to AI and B1 to Bj. So here we have I minus 1 because we didn't take account of we didn't take AI into account. So meaning that what's the best score we can have from A1 to AI minus 1 and B1 to Bj. Okay, and we have, because the last one is a deletion. So what's the score for deletion? Because it is a gap symbol, we are minus 3, minus y, and it is a gap symbol penalty for each gap. So we have to minus x. Okay, so we have to minus x and minus 1y. X is the gap open penalty for each gap, and y is the gap symbol penalty for each symbol. So we have one gap and one symbol or one character. So the total score will be Si minus 1 j minus x and minus 1 times y, and etc. We can deduce the score for this case. It has two symbols, so we will have minus 2y because it has two gap symbol, well, minus 2 gap symbol penalty. But you only have a gap right here because all the gap end at the end. So all the penalty for a gap open penalty will be 1, so minus x. So by definition, Dij means the maximum score for any alignment between A1 to AI and B1 to Bj ending with a deletion. So we enumerate all the possible alignment ending with a deletion, and we want to find the maximum. So we just take the maximum over all the possible cases we listed here. So for the first one, Si minus 1 j minus x minus 1y is this case, which in between AI and Bj there's no extra character. And similarly, minus 2 will correspond to this case where there's one character in between AI and Bj, and etc. Finally, we will end at a time where there's no more character we can use, which is Si minus I j, because the I for the definition Sij, I and j must be either 0 or a positive integer. Sorry. So the final form will take this form: maximum as I minus k j minus x minus ky, and k from 1, which corresponds to this one, and which corresponds to this one. Okay, and from k from 1, this one, until k to I, this one. Okay, and we can use a simple change of variables. which maybe you learned in your calculus in freshman, and to change I minus k to u. And after a series of deduction, we can get the form that dij equals maximum di minus 1j minus y, or etc. You can just see the formula here. I will not iterate every the details here for time concerns. Okay, summing up, we obtain the following recursive form for dij. So dij is here. So you can see the recursive form for I and j. Well, take the maximum over the previous one, I minus 1j, and also the I minus 1j, but for the s. Don't forget the definition. D means the maximum score for the two sequences with a deletion. And the definition is for s is the maximum score for the alignment between two sequences, but it doesn't require any ending like deletion or insertion. Or similarly, we can deduce the recursive form for insertion. So we can find the symmetry here. For deletion, the recursive take part in the first argument, which is I. Okay, I minus 1, I minus 1. And for insertion, since it is by definition is a symmetry to deletion, you can swap sequence 1 and sequence 2, and deletion will be an insertion. So the maximum you can just swap I and j to get the form here. So j minus 1, j minus 1. But the remaining parts are the same. Okay, here, so we're summing up. We get the recursive formula for dij, aij. Okay, so why we want to calculate this? Because don't forget what's the initial incentive for calculating d and I, because we want to calculate the maximum score between two of an alignment between two sequences. But there are three scenarios. So we first initially not initially we started by calculating the recursive form for any alignment with a deletion or an insertion. But in general, we want to calculate the Sij, which means there's no requirement for any ending. Okay, so we just take for Sij, the maximum score of any alignment between A and B, sequence A and sequence B, we will take the maximum over the three cases. An alignment ending with a deletion, which is Dij, and the second one is an alignment ending with an insertion, which is Aij. And the third case, the case one, is an alignment which is the maximum, the optimal score for I minus from the prefix A1 to I minus 1 and B1 to Bj minus 1. And we calculate the score between character AI and character Bj to find out whether it can be that means depending on the match or mismatch, it will affect whether it will be optimal or not. So we take over the maximum over these three cases. So the final form will take like this. For this one, the first one is the optimal score for the prefix a1 to ai minus 1 and b1 to bj minus 1 plus the weighting for AI for the comparing AI and BJ. And also we take this case 2, which is a deletion, dij, and also in this case 3, which is an insertion, which is a iij. Okay, we have a recursive formula which intertwined between three formula, which is Sij, Dij, and Iij. So get back to the dynamic the problem. We want to calculate the Sij. So how can we calculate it? By filling out the dynamic programming table. Okay, first of all, we will take the example and the class, which is in the lecture, as for the first sequence is AA and the second sequence is ACCA. If you go back to the first page, you can see it here. The first sequence is AA and the second sequence ACCA. Okay, so you have to create a table for each recursive form. For the first one is S, and the second one is D, stands for deletion. The third one is I, stands for insertion. And for the row, you can put each character for the first sequence A. And for each column, you put the character for each character for of the second sequence ACCA. Don't forget that our index of sequence start with 1, but in the boundary condition we will start at 0 for both I and j. Okay, so after we created this table, we will start to calculate Sij in this case, which is S2, 4. Alright, so we can just filling out the table one by one. So for we have the recursive form. The second step is to find out the boundary condition, which means what is the boundary condition is that for I, what's the value for I equals 0, and what is the value for j equals to 0. And finally, we'll get our answer by the filling up the table. Okay. So don't forget the definition for a deletion means that sequence 2 must end with a gap symbol here. So it is impossible for sequence 2 to end if the first symbol has nothing. You cannot end second sequence with either A, C, C, or A, because the second sequence in this case will always end with a gap symbol. So it is impossible. So the score we will initiate the boundary condition with a minus infinity. For I equals 0, this means no character here, but the character must be a gap symbol. It cannot be A, it cannot be C, it cannot be C, it cannot be A. So it's impossible here because there's no character input for sequence 1. Similarly, for an insertion, this since we for j equals 0, there's no character for sequence 2, so there's no bj. So you can, but sequence 1 have to end with a gap symbol, but in either in I equals 1, meaning that the first sequence will end with A. So it isn't possible. So we will write down, fill this entry with my negative infinity. And also, it's not possible for I equals 2 to be A. Also, it's minus infinity. Okay, let's see. And also, for after filling initialize I equals 0 and j equals 0 for both for d and I respectively, we start filling up the remaining entries. For I equals 0, meaning there's no entry here, and j equals 0 also means that there is no entry for sequence 2. But for this case, since there is already a gap here, okay, what is a gap? Because why it is not negative infinity? Because j equals to 0, meaning that there's no character, so it can be a gap symbol here. But since it is a gap symbol, it will be penalized with the gap open penalty of -4. Okay, but why you may ask why there's no gap symbol penalty? Because for I equals 0, sequence 1 doesn't have a character. For a gap symbol penalty, it only take in effect if another one is not a gap symbol. So for this case, both for sequence 1 and sequence 2 is a gap symbol. So we only will have the gap penalty, the penalty for the gap open penalty. So there's no gap symbol penalty here. Okay. So it's gap. We already calculate the gap open penalty here. But if the sequence 1 is I equals 1, which is character A, and j equals 0 is the gap symbol. Here, we will have both the gap penalty -4 and also the gap symbol penalty, since we already have a character here for sequence 1, which satisfies the condition for a gap symbol penalty. So we have to subtract additional gap symbol penalty -3. So the score for this entry will be -7 because it still only has a gap, right? For this one. Similarly, we can add again calculate the score for this entry, which is -7 subtracted by 3. Why? This means that for both I equals I equals 1, and I equals 2, we will have a gap symbol for this position. So it is -7 deducted 3, which is -10. Or you can, how to say, let's see. How to explain this? di d1 0 D10 0 0. Okay. Okay, we can maybe we can come back to the definition of Dij, which means the maximum score. For example, I equals 1 and j equals 0. Let's say here I equals, let's see, gather I equals for example this entry. Want to discard this entry. I equals 1 and j equals 0. I equals 1 and j equals 0. Okay, so the definition here is the maximum score between of the alignment between that's between A1 and nothing, empty. Okay, so there's no and empty string. Okay, so since it's an empty string, you have to introduce the gap symbol for introduce one gap symbol. So etc. Similarly, if I equals 2, meaning that it's the maximum score of the alignment between A1, A2, and an empty string. So you have to introduce two gap symbol at here. So two gap symbol will have two gap symbol penalty, which is minus 3 times 2, which is minus 6. And we have also subtracted, the value also has to be subtracted for the gap open penalty. So it's minus 6 subtracted by 4 is minus 10. Okay, so maybe it's more clear if we go back to the definition of Dij. Okay, just on maybe kind of obfuscated, but can just go back to the definition in the lecture and it will be more clear. Okay, so we have minus 10 here. So similarly, so since for sequence 1, if I is equals 0, it's been an empty string. So we have to introduce a gap symbol for each j. So and a gap symbol is minus 3, and for each gap we have extra gap open penalty here. Okay, you can imagine under the previous case where let's say the what's the best alignment for this entry? It will be for this entry is D I equals 1, I 1 0. So again, the maximum score between A and empty string. Okay. Okay, so the best alignment may look like this one. For sequence A is between A, okay. So sequence 1, sequence 2, which is empty. So sequence 1 for D10 is only A, so it's A. But sequence 2 is an empty string, so we always have to introduce an a gap symbol here. Similarly for 20 is between sequence 1 and an empty string, which is A. And there's 2 gap symbol here. So 2 gap symbol, the 2 times -3, and is a gap here. So we have to subtract 4 additionally. Okay. So basically it's symmetrical for both ID and for deletion and insertion, just the position of I and J. So we can deduce the same. We can arrive at the same conclusion for the table for insertion. Okay, here for -3, -7, -7. For each additional character, we have to introduce, and also a corresponding gap symbol. So there will be an additional gap symbol penalty, -3. So similarly, we can fill out this table. So for both these, I equals to 0 and j equals to 0, the boundary we have already finished the boundary conditions for both deletion and insertion. Okay, come back to our main table, which is the maximum score of event alignment between 2 sequences with no restriction on the end of the on the alignment. So we can just define the basic case here is like let us say if the score the maximum score between 2 empty string, we define it as 0, so we can just put that 0 here, and starting from here we will use the recursive formula we introduced in the previous slide to fill up the whole 3 tables. Sorry, just charge my laptop. Let's see. Okay. First of all, in fact, for the boundary condition is similar to D and I, but you can also calculate this boundary condition for S by the recursive form, especially because like I for the j equals to 0, since j cannot be less than 0, so the recursive form may not take effect, but we can use this same the same reasoning we elaborated before for D and I to calculate that the boundary condition for I equals to 0 and j equals to 0 is the same for D and I. So you can see here -7, -10, -13, -16 is the same for I, especially because we want to calculate the maximum. So comparing minus infinity and minus 7, it must be minus 7, which it has a maximum value, which is larger, right? So we can just take this part and copy this row into this one, and similarly we copy this column into this column. So we initialize both for D, I, and S. Okay. Oh, you may ask why it's not minus 4 here, because S, for the definition of S, it is the maximum score of an alignment between two sequences without demanding any restriction on its ending. So it doesn't have to be a gap symbol at the end. So we can just define 0 here. But why is it minus 4 for D and I? Because we, under this two scenario, both of the alignment will either be a deletion or an insertion. So it must have a gap here. So for any gap existed, it will be penalized with a gap open penalty, which is minus 4. Okay. So we find out the recursive form for SDI. We created the 3 tables for each recursive formula, and we initialize the boundary conditions by observing the definition of each notation. And the next step will be filling up these tables by our recursive formula. Okay, we can you can fill up these tables as you want, but I will fill up this table by the order of D, I, and S. So so if we want to calculate the D11, so what is D11? Let's see. So D11 is a maximum of D01 minus Y and D0J minus X minus 1. So we just represent each entry by represent each item by the corresponding entry in the table. So this is Dij. So which is I minus 1j? It's the entry one row above here, the current entry, right? So the green one is here. So the light blue one is here. And the dark blue one is S, which is the same position, which is I equals to 0 and j equals to 1. Okay, 0, 1, but it resides in S. Okay, so that's quite simple because it is in minus infinity, so it must be the value must take the maximum must be the one for the for the dark blue one. So it's minus 7, minus 4, and minus 3, which is minus 14. So minus 14, and we just calculate I here. Similarly, we again represent each item by the corresponding entry with a colored entry in this table correspondingly. So here again is minus infinity. So the value we must take from the dark blue one here. Okay. And finally, you want to calculate Sij, which is Si minus 1, j minus 1, which is diagonal here. Okay. S11 equals to maximum of S00. Okay. 1, 1, 0, 0. And also you have to calculate the value for D11 and I11, which we have already calculated in the previous two slides. So we just so we want to find out the maximum of these three items over these three items. So what is W, AI, and BJ? What is AI? AI is A. BJ is also A. So WAA is a match if A equals to B. So in this case, it is matched, right? A equals to A. So it is a plus 8. So 0 plus 8 is 8. And the remaining two are O negative. So it will have the maximum must be the first item here, which is 0 plus 8 is 8. Okay. So we just iterate over and over again in the order of D, I, S. So you can see if we go through the slides, we'll see we'll calculate D, I, S. For each I and J, for each position I and J, we will calculate first D and then I, and then finally S. Why? Because the recursive form, well, we have you will have to take the maximum over both D and I. So you have to calculate first D and I before you calculate S. So we you can just and we just take calculate D, I, and then S in this order. So again, DIS, 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 DIS. So it's a very routine work, and the formula was quite clear. So we just we will not go iterate over all the details here. If there's any error, please do let me know in the comment. And finally, we will arrive in the end of Sij. So, okay, so we fill up all these three tables here. Okay, so what's the value uh we wanted is 6, right? We want to calculate the maximum score between AA and ACCA, the maximum score of an alignment between sequence 1, which is AA, and the sequence 2, which is ACCA, which is 6. And okay, we know the maximum score. So what's the alignment? So in this case, if we write up a program to implement the recursive dynamic programming here, you will have to remember every step. So basically, what is the maximum for this one? The maximum over the light blue one, dark blue one, and the orange one is the light blue one. So you will have to calculate for each I and j, where maybe you can save the pointer or save the previous position, and it will be used in our backtracking here. Okay, after filling up the table, we know the optimum alignment score, but we want to you also have to know what's the best alignment, which will render this value the optimal value, right? So the final step, the first one is represent we know the recursive formula, and we represent our answer as the recursive formula, and we initialize the boundary condition, and we fill in all these tables by our recursive formula, and finally we will use backtracking to find out what's the best sequence, best alignment between the two sequences. Okay, so I just add the screenshot for the previous step, which memorized, or which documented the maximum score between the 3-1 here. So you can see just a representation of the programming or backtracking. So you may still put in more effort in how to reduce the memory space that is allocated for 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 log and all these backtracking pointer or position, whatever. Okay, again, for Sij, the maximum will take place upon I. Okay. Similarly, why there's only three? Because the recursive formula for I is only will only take maximum over 2 items. Okay. Only the recursive formula for S will take maximum over 3 items. So here, over 2 items, and the maximum was the light blue one. Okay. And again. So by backtracking, we can know the maximum, the trace which with a trace of actions, which actions either deletion. What's a deletion? Meaning that deletion is we introduce in the gap symbol to where? To the second sequence. Okay, so insertion is introducing the gap symbol to the first sequence. Okay, here after the backtracking, we will print out the best alignment by carry out all the options suggested during the path of the backtracking route. All right. So starting from 0, which means there's empty string to empty string. Okay, so we will enclose the already discovered character to document the progress of the alignment. Okay, so we just traverse the route of the backtracking here. So the first one is the diagonal here, which means that it is a alignment scenario, which is AA. So the alignment, the first character is AA. Okay. The second one is an I. An I means an insertion, that is, introducing a gap character to the first sequence. So here, we introduce a gap character into the first sequence, but we explore an additional character for the second sequence. So we will expand this, we will enclose this character here, A and C. Okay. Similarly, here, it is again an insertion. Okay. So we just again introduce a gap symbol to the first sequence here, and we will explore an additional character for sequence 2. Alright, ACC. Okay, the next step is quite crucial, especially because it traces back to the same position. The index is the same. It's 1, 3, and so 1, 3. But we already have explored 1, 3. So there's no more we need to add to the alignment for both sequences. Okay, for the last step is again an alignment case, which means that we just need to introduce the last character into the alignment, which is A and A here. So we know the best alignment will be A gap A and ACCA. And the maximum score will be the value for in A's S2 4, which is 6. Okay, so in retrospect, the whole process is to um, you have to know the definition for what we first of all we want to calculate the optimum scoring of an alignment between two sequences under a fixed scoring scheme. We uh, we uh, we observe the recursive form or we deduce the recursive formula, and we are later we observed the three scenarios for all possible alignment, which can be an aligned pair or a deletion or an insertion depending on its end, right? So for both scenarios, we deduce its corresponding recursive form. After finding out the recursive form, we created three tables for these three recursive formula, and we started to fill out these three tables by initialize its boundary condition, which means the entries with either I equals 0 or j equals to 0. And under this case, because the recursive formula can take effect or cannot, may not, is not, uh, does not work because the range for I and j is at a boundary, which how to say, sorry, kind of stuck here. But just because I cannot, the first argument cannot be negative, so you have to come back to the definition for D, for I and S. Okay. So after initialized the boundary conditions, we filling up the tables by the recursive formula. Okay. And don't forget uh, to memorize or to document the previous, where was the maximum, was the position, was the item you get the maximum from in order for the backtracking step, which is the last step. Okay, filling out all these tables, and finally we use the backtracking method to find out the route from to empty string to the complete string, and we encircle each explored character, and along the way we traversing the route, which is the backtracking route, to get the optimal alignment between the two sequences under this scoring scheme. Okay, Okay, that's it. So a lot of details. So you can just walk through like the example here. If there's an error or or misapprehension in class, please do let me know. You can just send me an email or whatever. Okay, let's end here.